Hello everyone and welcome to the problems of chapter 30. I will make a quick summary about it and then we will solve them. So first, Faraday's law here, the EMF is created to oppose the change of the flux with time. So minus here, the meaning of the opposing term. And remember that the flux of the magnetic field is equals to the magnetic field magnitude times the surface area of the loop times cosine the angle between the vector B and the vector S. هلا الفector B is easy بس الvector S remember هو الnormal vector to the surface area. هلا remember that length is here to help you to find the direction of the current induced by the change of the flux of the magnetic field. Now, to find the direction of I, Lance always blame the magnetic field for the change of the magnetic flux. So حتى إذا الsurface area هي كبرت هو دايما بحط الحق على البي. So imagine that you have a loop ما في current بقلبها بس بعلمي كان المagnetic field 2 تسلا فجأة رح يصير 5 تسلا. So since 2 صارت فجأة 5 nature ما بتحب هيدا التشينج so it will create a current in a way that it will create a B induced opposing هودي 5 تسلا to regain 2 تسلا again so رح يخلق هو 3 تسلا down and that's how you find the direction of the current using the right hand rule تبع curved fingers you put your thumb down okay with B induced and the current is circulating with the direction of your fingers. So please remember that the I induced is always related to the direction of B induced, not the B external. Now if the flux decreases, Lance blames the B إنه هو بيقعد يتخيل إنه B has decreased from 3 Tesla for example to 2 Tesla. Yeah, sure, I'm giving some values, but it doesn't mean إنه it's always هيك يعني. Sometimes it's a function of time or whatever. So since B has decreased, the B induced should help the B initial, the B external. So the B induced should be, think about the direction of B induced. Yes, it should be 1 Tesla in the direction of B external. And then you use the right hand rule with the curved fingers to find the direction of I induced. In this problem, they are giving you the figure where B external is given as a point, يعني you are pointing to yourself. It's a direction that is saying and B is going out of the page. Now, the flux is given as a function of time 60 squared plus 70, where phi b اللي هو الفلux is given in milliwebers and t is in seconds. And the question A is, what is the magnitude of the EMF induced in the loop when t is equals to 2 seconds? So first you have to find the magnitude of the EMF, then you replace the time by its value. هلا هون you have directly the flux as a function of time you derive it تطلع 12t plus 7 أي متى هيدا ال derivative is positive إذا t أكبر من minus 7 over 12 so أنتو بما أنه time is always positive يعني أنتو your flux is always increasing with time and then you replace the 2 seconds in 12t plus 7 you will get 31 millivolts لأنه ما تنسوا ال flux is in milliweber. هلا to find the direction remember to use إنه هيدا ال B since it's in increasing يعني كمان ال B induced is opposing ال B initial so إذا هيديك point هيدي رح تكون X in red and you can find the direction of the current. Problem 8. A uniform magnetic field B is perpendicular to the plane of a circular loop of diameter 10 centimeters, formed from a wire of a diameter of 2.5 millimeter وبعدين عاطيني resistivity etc. At what rate must the magnitude of B change يعني بدهم dB over dt to induce the current 10 ampere in the loop so 10 ampere is given. هلا انتم بتعرفوا انه دي بي اوفر دي تي هي مخبيه بقلب الدي فلكس اوفر دي تايم سو لازم نجيب الاي ام اف اي بس أنا مع الcurrent I ومع الresistance R لأنه وقتها بيعطوني الresistivity والdimensions يعني أنا مع الresistance R. Remember to use الفورمولا rho L over الarea. هلأ الfirst formula E equals d flux divided by dt هي طبيعي نستعملها لأنه سألوني عن dB over dt. وتاني function بقلب السيستم اللي هي I equals E over R هيدي الأومز law العادية. هلأ since مع ال I ومع ال R بدلل لي only one unknown اللي هي derivative of the flux والflux هو B times A times cosine the angle. الangle between A and the B ال A vector هو parallel to B لأنه ال A vector هو perpendicular to the A surface area. So ال cosine 0 is 1. That's why directly حطيت derivative of the flux حطيت محلها derivative of B times A. ال B هي ال magnetic field ال A هي ال area of the loop. هلا هون focus I have two diameters في عندي 10 centimeters وعندي 2.5 ملم 2.5 ملم رح عوزها للresistivity وللresistance formula اللي هي in brown بس ال 10 سنتيمتر I will use it الاريا الكبيرة اللي هي باي ار سكوير تبع الفلكس اوكي so you replace هلا طبعا ال A is constant so بتطلع برات الديريفاتيف so I equals A over R dB over dt and the area is pi r squared. هلا since مع ال I ال current ومع ال resistance ومع ال area I can find dB over dt it is 1.5 Tesla per second. Number 58. Suppose the EMF of the battery in the circuit shown varies with time t so that the current is given by I of time is given by 3 plus 5t, where I is in ampere and t is in seconds. Take R equals 4 ohm and L equals to 6 Henry and find an expression for the battery EMF as a function of time. Apply Hooke's law for the loop and let's take it clockwise. Now the EMF is positive لأنه it's going with the loop minus IR minus LDI over dt بتاخدوهم لتاني ميل بتصير E equals IR plus LDI over dt. Since مع ال I as a function of time كتير هين لقيت DI over dt I just derive it بتطلع 5 لأنه 3 plus 5t derivative تبعها is 5. You replace and you will get 42 plus 20t. 20t. In problem 56, we have an inductor that has 25 turns and an ideal battery has an EMF of 16 volts. The figure gives the magnetic flux phi through each turn versus the current I. So هيدا الفلux of one turn. If you want to find the total flux, you have to multiply it by 25. So the vertical axis scale is given, the horizontal axis scale is given, and if the switch S is closed at time equals 0, at what rate dI over dt will the current be changing at time equals هالقد. So دايما find the rate and then you replace the time at the end. We know that the flux of one loop هي L times I, and since we have n loops so بتصير الإندكتنس L equals n phi over I. phi over I هي the slope of the graph. Now it's easy. You multiply this number by 25 بصير عندكم 50 10 minus 2 هي ال L in Henry. Remember the purpose هو to find the derivative of I with respect to time. I is given as the function تبع ال growth of the current هي 1 minus exponential minus t over tau والتau هي L over R. Whatever. هلا شو derivative of exponential u؟ بتضل exponential u بس ما تنسوا تعملوا times u prime يعني times 1 over tau. اوكي so بتصير r over l times exponential minus t over tau already عندي e over r ما تنسوا derivative of 1 اوكي هي 0 وفي 2 negative so بتصير plus exponential derivative and you substitute